All right, so we're on section 7.5, which is on proportions and triangles. So the first theorem that we have is called the triangle proportionality theorem. Okay, and it says that if we have a line that's parallel to another line in a triangle, then it divides the sides proportionally. So basically, like TR over TQ ends up being the same as RU over US. You guys see what I'm saying? Like if this was 3 and 4 and this was 6, this would be 8. Does that make sense? Okay, and then the converse says if they divide proportionally, then the lines are parallel. So it goes the opposite way, right? That's what a converse is. So if we do some examples, I think that would be the easiest way to show this. So it says in the figure below, BD is 2, DC is 2.5, EC is 4, what is AE? So we'll call that X. You guys are flipping through all these notes. Do you find them? All right, so we're going to set up a proportion. Basically what this proportion comes from, guys, everybody look up here, is we have a big triangle that ends up being similar to the small triangle. All right, and we can go through a proof and show that these pieces divide out proportionally, but we're not going to really worry too much about that proof today. We're just going to use the theorem. So it says 2.5, yeah, divided by 2 is equal to 4 over x.
Wait, why is it not 4.5?
Oh, is it 4.5? I don't know. Did I mess something up? Oh, are you saying because the big triangle?
Yeah.
Yeah, so basically this ends up being 4.5, and you could say 2.5 over 4.5
Yeah.
equals 4 over 4 plus x. That's what we've done in the past, right? So we can do that. That would work. And you can cross multiply, and it solves. I mean, you get the same thing for x. But basically now we're saying that just the parts of the side end up being proportional. So we can do 2.5 over 2 equals 4 over x. Do you guys remember that theorem where we had a over b equals c over d, and we were able to add 1 to both sides? So when we add 1 and add 1, we ended up getting a plus b over b equals c plus d over d. Do you guys remember that theorem? No? It's been a while. Yeah, so that's what this theorem's coming from. It's like if you take the whole piece and you subtract out by 1. So if I subtract out b over b and subtract out c over d, then they're proportional. So, all right. So anyway, so you can set it up either way if you want. So you could set it up with the 2.5 over 2 equals 4 over x, or you can set it up with 2.5 over 4.5 equals 4 over 4 plus x. But either way, we get 2.5x equals 8. So x equals 8 divided by 2.5. Which is 3.2. And that's our answer. So let's say we had done it Charlie's way and we had said 2.5 over 4.5 equals 4 over 4 plus x. Do you guys see what he's saying? Like the whole side. If you cross multiply here, you get 4 times 2.5 is 10. So 10 plus 2.5x equals 4 times 4.5, 18. So 2.5x equals 8. And so see how you end up getting the same thing. You get 3.2. So it works either way. All right, so number 2, it says in the figure on the right, AB is 25, BC is 10, ED is 8, and AE is 20. So it says determine whether or not the lines are parallel to each other. So we know that they're going to be parallel to each other if the sides are divided proportionally. So this is using the converse of the theorem. So if the sides are proportional to each other. So if I have 25 over 10, and if that's the same as 20 over 8, then those lines are parallel. So 25 over 10, if I divide by 5, I end up getting 5 over 2. 20 over 8, if I divide by 4, I end up getting 5 over 2, right? So this uses the converse of this triangle proportionality theorem. So yes, by the converse of the triangle proportionality theorem. Okay. So I'm not going to worry too much on the test about using the converse or anything, proving that lines are parallel. I'm really worried more about setting up the proportions to solve for like an x or a y. Okay. All right, so with that comes this theorem, And it says if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Okay, so do you guys see how this is kind of an extension? Like if these intersected, they would intersect in a triangle. So we could say like this distance over this distance equals this one over this one. But notice how we don't have those distances on the left. We're not seeing that in our picture. So what we're using instead is that UW over WY is equal to, what do you guys think? Max, you with me? So UW over WY is equal to VX. Yeah, VX over XZ. So we just go in that same order. So it's still kind of that triangle proportionality theorem. Do you guys see it? We don't have a name for this one. All right, so then the last one that we're going to learn, so that was the first theorem. So all of these like sides are divided proportionally. As long as we have, notice how we have to have parallel sides in order to do that. So the last one involves a ray bisecting an angle. Okay, and this is a weird one too. So everybody look up here. This distance AC divided by this distance AD ends up being this one divided by this one. Okay. I don't know what the proof is for this. I don't think I've ever proved this. I should go and look it up in a math book. But I know that thrills you when I show you all of the proofs. So I'm going to skip it. Can we remember this? Yeah. So here's what we have. So in this case, it says an artist uses perspective in order to draw a row of parallel trees. She checks the drawing by measuring the distances between the trees. So AB is 2.4, BC is 1.4, CD is 2.2, KL is 2.2. What are LM? So I'll call that X. And LM. So LN, LM, and MN. So let me call LM X and MN Y. Okay, who thinks they can set up an equation in order to find X? It's really not rocket science. It's just you're matching up the sides, right? So you're saying this over this equals this over this. What do we say? No one, crickets. 2.4 over, 2.4 over like 1.4 equals 2.2 over X. Or like Cassie said, she said it this way, 2.4 over 2.2 equals 1.4 over X. You could do it that way as well. You guys see it? And then we solve for X. So we're going to cross multiply. Cam, you doing it? So I end up getting 3.08 equals 2.4x, and I divide by 2.4. So I get x is equal to 1.283 repeating. Okay, so that was LM. All right, you could write it as a fraction if you do math 1. It would be 77 over 60. All right, so now that I have that 1.283 repeating, can I get what y is? Yeah, and you could do it with any part. I could do the 2.4 and 2.2 together again. So I could do like 2.4 over 2.2 equals 2.2 over y. I could do that. Or I could do the 1.4 over 2.2 equals 1.283 repeating over y. Okay, just make sure if you found this answer, this 1.283 on your calculator, keep it on your calculator. Colin, put it on the bookshelf. So we have 1.283 repeating times 2.2. We're going to divide by 1.4. And so we end up getting y is equal to 2.016 repeating. And that's y. Does it make sense? All right, so number 7. So it says in the diagram CAD, I think my C got cut off. That's a C down there in the bottom left. So CAD is congruent to DAB. I know that brings you joy that it spelled out dab. Don't you love when it spells out words? All right, so we have our angle bisector thing going on, right? Okay, so because of this, like these two triangles definitely aren't equal, like they're not congruent to each other, but they are proportional, like their sides end up being proportional to one another. So this 9 over whatever this BD is ends up equaling 15 over whatever this one is. Okay, that 146 is the page number, so ignore that 146, sorry. That's on your notes, right? Page 146. Okay, so right now I have two unknowns. I don't know what BD is or what CD is, but I at least know how they're related. So what number am I not using that I need to use? I use 9. 14, do you guys see it? So what we have to do is we have to think about one of these being x. I don't care which one's x. So we're trying to find the length of DC. I would probably make that x. So then what's BD going to be? 14 minus x. It's the rest of it, right? So we're going to set it up and we're going to say, well, we have 9 over 14 minus x equals 15 over x. And then we cross multiply and solve. Can you try it? So I get 9x equals 15 times 14 minus x. So I get 210 minus 15x equals 9x. I add the 15 over. So I have 24x equals 210. So we end up getting x is equal to 8.75. Okay, so that was the length of DC. If I asked you for the length of DB, then you would just do 14 minus that answer, right? Easy enough? All right, so let's try this one. So it says in the figure AD bisects BAC. So that means that we have these two angles are congruent. BC is 7, so this whole thing's 7. AB is 4.5. And AC is 7.5. So we're trying to find the length of DC again. So DC, I'm going to make the x, because that's what I'm trying to find. A lot of times it's nice when you have x equals in the end, and that's what you wanted, right? So BD, I'm going to make 7 minus x. Okay. And these sides are divided proportionally. So that 4.5 over the 7 minus x ends up being in the same proportion as 7.5 over x. So we get 4.5x equals 7.5 times 7 minus x. So we get 52.5 minus 7.5x. I don't know why I put it in parentheses. Equals 4.5x. All right, and we add over. 7.5 plus 4.5 is 12x equals 52.5. So our answer is x equals 4.375. I really didn't give you any nice numbers on this notes, did I? So mean. Wouldn't it be nice if everything was like x equals 3? Every measurement you ever took in your life was just nice and even. All right, number 4. In the figure, SV bisects RST. So again, we have these angles are the same. ST is x minus 5. TV is 7.5. VR is 12.5. And RS is x plus 5. So see if you can set up the proportion. So we have x plus 5 over 12.5 equals x minus 5 over 7.5. Do you guys have something like that? You could have different variations. You could have like x plus 5 over x minus 5 equals 12.5 over 7.5, right? There's lots of other things you could have. We then cross multiply, so we take that 7.5 multiplied by x plus 5, and we take the 12.5 multiplied by the x minus 5. That. So 7.5x plus 37.5 equals 12.5x minus 62.5. Then we're going to get everything on one side. So I'm going to subtract the 7.5 over, and I get 5x. And I'm going to add the 62.5 over, and I get 100. So I think x is equal to 20. Did you guys get that? All right, look what we're solving for. So on the last one, we found DC, and that was what we had set our x equal to. This time we want SR and ST. So what's SR? 25, right? And then ST? 15? That's our answer. Okay? All right, let's skip the last one because I think I have something wrong with the picture. So we'll see you there.